Let me introduce you to my Warco drill press. But could it be improved? Welcome back to episode 11. So while you've been away, I managed to spray this adapter here. This is the adapter collar that I made between the handle and the quill, just to move the handle away and give me clearance at the top there. It's this Rust-Oleum gunmetal grey, sort of a slightly metallic finish to it. I used it on my CNC machine on some of the box sections, and I really like the colour and the finish that it gives, so I've done that. That should keep the rust at bay. In the last episode we also got the table mounted, which does mean we can start to drill some holes in some of the later components. The thing is, before we get too carried away with that, we need to have a look at the motor cooling. So in an earlier episode you probably saw me install that 3-phase motor there. So in the UK that would run at 50 Hz nominal, in other markets might be 60 Hz. And on the end of the rotor shaft that goes all the way through the motor, at the top there's a fan. It's a white plastic fan, unidirectional fan, and that's enough to keep the motor cool at that nominal speed, 50 or 60 Hz. But of course one of the advantages of running it from the inverter and with the variable speed control is we can run it at a range of speeds. The downside is, because of that fixed fan, when we go to lower and lower speeds, there's kind of an exponential drop off, or probably even a cubic drop off of the airflow, and there isn't really enough airflow at the lower speeds, and you can burn these out. So I know I've got the over temperature sensor in here, but I don't really want to risk it, and the supplier highly recommends you add an additional fan when you're running it below the 50 Hz. So before we make up the mounting for the auxiliary fan, we just need to see which way it wants to draw the air. Now you might be able to see that white fan down there. It's a straight bladed fan with a scoop at the bottom, and basically that's a unidirectional fan. So if it's going forward or reverse, it'll always pull the air in the same direction. So we've just got a bit of tape here. We'll just see which way that is, and then we can mount our auxiliary fan to make sure it's helping and not hindering. So we've got it in, yeah, we're in forward, so we'll run it forward and see which way it pulls the air. Starting now. Okay, so the fan was going this way, it was going forwards, and it was clearly pulling the air down. So now I'll put it into reverse. Try it again. And now it's going the other way, and it's also pulling the air in. It's going that way. So whichever way it goes, it always draws air in and over the motor. Right, so we just need to make sure we put the auxiliary fan in the same direction. So in terms of fans, there was a couple of options I was looking at. This is one I pulled out of a cabinet or something years and years ago. So it's a mains powered one. It's 21 watts, so it's quite a beefy, heavy unit. Probably chuck out a fair bit of air. And then in terms of wiring it, I could either put some crimp terminals onto here, or more likely just go direct onto the solder terminals there. So that is an option, but the way I've got the control unit configured at the moment is it trips a 12 volt relay. So I'd have to then hook that up to a contactor to be able to use this, and there wasn't really space in the control box to do that. And my plan was to run a 12 volt fan, so I think we'll probably leave this one. Yeah, and we'll go with the 12 volt option. So we've got a couple down here. So these are a bit more suitable. These are 12 volt fans. This one's 120 millimeters and this one's 140. This one was out of an old PC I built years ago. I don't need it anymore. But it has got these LEDs around there, so it glows bright green, which is not really what I want, but the size is a pretty good fit on top of the end of the motor. It does push a lot of air. It pulls actually more like 3 watts, but yeah, that's fine. It has a slight tonality to it, which may get a little bit annoying when it's running, but it does push a lot of air. The one on the right here, 12 volts, draws about 2.2 watts, a lot less. I think subjectively this does not push anywhere near as much air as that, even though it's a lot larger. Maybe because this is a name brand and this is a no-name brand, not sure. But it is very quiet. So it's between the two. It is also a really good fit. Sort of that diameter there is about the top of the the motor itself, so it might make mounting a little bit easier, but I could probably make either work, to be fair. So let's just fire them up and then you can hear them, and then I'll make a decision on which one I'm going to go for. Okay, so this is the one on the left, the Casa. Okay, so this one's now running. Maybe you can hear that tonality. 12 volts, just pulling around 3 watts. There's a fair bit of air coming out of that, so that's nice, but as you can see it does kind of glow green, which I'm not sure is what I want. And if you have a look at that one, I don't know if you can hear the difference really on this microphone up here, but that is a lot quieter. It doesn't have that annoying tone, but I don't think that's shifting anywhere near as much air. Now, how much air do we need? Well, the answer is I don't know, but we do want to push some air across because the fan that's already on there is going to run very slow at those low speeds, so it's going to be a bit of a decision to be made between them. Let's run them both at the same time, and just so we can give you a visual comparison. Alright, let's run them both at the same time, and then, well, you know, just for you, I've invested in this high quality airflow meter so we can have a little look and see how they compare. So let's fire it up. Right, and let's check the flow. Well, actually, as you can see, that's chopping it up. It's doing pretty well compared to. This is really scientific, I know. So we've got that versus. Yeah. So the smaller fan is actually kicking out a lot more air. So, decisions. Alright, so I've just taken the cover off the outside and then cut the wire that runs to the little LEDs that run on there, and I was hoping it would still run, and yes it does, but without the bling. Yeah, that really kicks out some air. It's going to be a little bit easier to mount this one, so I think this one's the winner. I just might tone it down a bit, maybe just put some black tape around it or something like that, just so it's not quite so bright. Right, let's go and get that mounted. I made up these two side brackets just out of a bit of 3mm scrap aluminium. So I'm using the CNC machine in manual mode just to get to the final dimensions. So we've got the two pieces ready to bend. They're oversized at the moment, so you can see they're just rough cut. Then when it's bent, we can work out and measure the final length and then drill the hole in the right location. I'll just put a shim in the back just to protect it as we start, so it doesn't mark the work so much. Here we go. And here I'm using the height gauge just to mark out the centres of the hole. Okay, so after a little bit of spray paint, that fan looks like this, so it's got a nice finish on there. And then I've also added this little 2-pin connector to the side to make it a little bit easier to fit. So that fan goes on there, kind of diagonally like that. Like that, there. And then those two brackets I bent up look like this. They've been spray painted as well. So they're kind of going to hook in. I've got this little 4mm bolt in there, and they'll just locate like that. And then the other end just picks up on there, and they kind of sort of pull down. There's sort of two hooks like that, just hold that in place. I've also got a grill on order that I'll clip in when that arrives, and that should work really well. Right, let's get it mounted. Okay, one side, we'll do the other. And the last last thing to do is just to hook up this connector for the power. Okay. So this is the cable that we just connected up to the fan up there. So all I need to do is clip it into this little bracket that I made up, and then that'll be the wiring done. Two. Alright, let's switch it on and see if it works. I think I can hear the fan running, it's pretty quiet. Brilliant, another job done. Okay, let's have a look at the box sections that run down either side of the machine here. So they perform a number of functions. One is they provide some stiffness between here and the main column to stiffen the head. But also, because they run all the way top to bottom, they also stiffen the column itself. And thirdly, they provide a surface at the front here that we put the main plate on, and then the rails mount to that. So sort of three functions in one. So I've just measured up the actual gap here rather than relying on CAD, just the actual gap we got. I've got the box sections down here, and I've already cut the ends of them square on the chop saw, and then I've just marked up the complete length there, so we need to chop this end off, and then we'll just make sure they fit in there, and then we can go over to the CNC machine and start spot marking out some of the features on here, and then we can finish off on the drill press with some of the bigger holes. Right, so let's get these chopped to length. Right, so we'll just offer it up into position and make sure it's going to fit. So it'll sit a few millimetres off the base there, just to give me some clearance. And then there'll be two fixings that go into the side of this plate through here, and they'll pick up on that face there. And they'll bolt in the same way, so there'll be a clearance hole through here, and it'll pick up on that back face, just go into the two M8 holes we got in there, onto this piece, and they'll be flush with this face as well. And then at the top here there's a kind of bracket arrangement that'll be welded on here with some slots in it just to pick up some threaded holes on here, so that will join this bit to the top plate, so tying the whole machine together. So we'll tie the head to the column, and then also on this front face here, this is where this 6mm front plate will go on for the rails, and then there'll be another one on the other side obviously. Yeah, so it looks okay. Just left myself a tiny gap there just in case. Yeah, I didn't want it to be a snug fit, so that's fine. So it's going to work nicely. So I've got the section clamped down into the CNC machine, and then I'm just using the spot drill just to mark out all the centres of the holes. So this is the cutout that allows the height adjust for the table to go in. There'll be a sub-assembly mechanism that go in there that will contain the drive unit and the two gears that link it to the ball screw. And then finally the finish pass on the cutout. And that's got us to this stage where we've got the holes spotted and marked out on both sides, and then we've got this hole cut out here for the height adjustment mechanism to go into. So this is the top of the box section. I'm just drilling and tapping out to M8, and that's where this kind of bracket assembly will go that will hold it onto the main head that will be about here. Right. Just using this little guide to keep it square to the work. I've drilled and tapped most of the holes now. It's just the really large ones to do. This is a 15mm drill bit, and that's just to give clearance for this socket head to go through. So that will go through there and then sit on that back face where there's an 8mm hole, and that's to bolt it into the sides. So we'll get some go fast juice on that and dial the speed in. And let's see if we can drill a hole. Okay, here we go. Okay, let's see how we do. Too fast. Well, I'll call that a success. That's really good. It was quite nice dialing the speed in. You could sort of dial it in by ear and just feel when it was just right. Really nice not having to change belts. Right, onwards. Just got the rest to do now. Okay, these will be painted, but I just thought I'd better check it fits first. So I've just got the first few threads started on the first bolts, and we'll just put the next set in. I just got to be careful I don't drop it down inside. I think I can just about get it out the bottom of the section, but let's not try it unless we really have to. Right, so let's get this one in. Just get a couple of threads on it so we've got a bit of free play still. There we go. Right, the next one at the back there. Okay. Tighten these up now. I haven't got those flush there, we just loosely assemble it. Let's see what we've got. Okay, so that's one side in. It went in okay. Okay, and there's the other side. So it's almost the same, except it's got a few extra features in there. So here's that slot close up. This is where the crank assembly will go into here. So you'll turn this handle, and through two bevel gears that will drive the ball screw, which is here, into this part here, and then there's a nut on that goes up and down. That moves the whole table up and down. So yeah, looking pretty good. And then you can see there'll be a front plate that goes on here, the 6mm plate. I haven't drilled the holes for the rails because that will be determined by the other plate first, and then we'll put the rails on and drill them right through into here. And then you can see some tapped holes in here. There's M8 tapped holes. They also hold the plate on there, so it's going to be a pretty stiff machine once we're all done. And then at the top here you can see there's 3 M8 holes that go all the way around, so there'll be kind of brackets sort of this shape that go onto there, and that bracket will be welded onto a plate that's virtually that shape, steel plate, and that will be bolted onto there. And then there'll be some pretty large generous clearance holes in that, and then that will allow me to bolt this bracket, which is bolted to this, to here, basically make that connection. Same on the other side as well. Looking good so far, very pleased with it. So the last thing to do then is to make this connection up here. So there'll be 2 pieces. One's a 6mm plate that goes in here and goes around that profile there, and it's held in place with these 4 fixings that go all the way through. So that's our 6mm steel plate. And then there'll be a C-section that I'll make up from another larger box section. I'll show you that in a moment. And that will go around here, the 3 sides, have holes in it to take these M8 bolts on 3 sides. And then that piece of section that's around there will be welded sort of here, here and here onto this upper plate, and that's what will finally make the connection. So I've got those pieces of material, the drawings over on the bench. Let's just go over there and have a look. And to make those brackets, we've got this material here, so there'll be 2 pieces cut out of this. This will be the flat piece that goes onto the sort of head plate at the top, and then this is a bit of box section that got left over from my CNC machine. This is the material I use for the large X-axis. I think it's 6mm wall or something like that. It's a pretty heavy gauge. And so what we'll do, we'll use that and chop it down to make these kind of C brackets. So here are the drawings. So this is the drawing for the flat piece. So there'll be 2 of these cut out of that plate there, 6mm plate. So there's nothing too fancy around the edge, just the profile and some holes for the bolts to pass through. The main thing that's quite interesting here though is I put this pocket on here. So it's only 0.1mm deep down here. And effectively that forms a bit of a guide, because what I've got to do is take this section that's too big at the moment and chop it down, so because it's too long and it's too deep this way. So I'll basically have 2 L shapes out of this, and then I'll weld them back together, and I can use this as a guide not only to make the correct shape, but also get it in the right position on here so it can get welded onto this plate. So kind of C shape will stick up like that. So that's the flat pieces. And then for the 2 sort of C shapes that I've got to cut out of here, that's the drawing there. And again, nothing too fancy. So it's a C shape there, so it'll be sort of that shape. But I've got to then crop this down because it's too long. And then there's just 2 holes. Actually, there's 3 holes in it. There's one in here, here, and one on the rear face. And this is the sort of forms a bit of a tube or a node that the section that comes up down the side of the drill press, that goes into there. And what you might notice as well is, instead of being just a notional 40mm, these are 40.1 and the hole is at 20.1. That means this is 0.1 longer than it kind of needs to be, and that 0.1 is the bit that will sit into this 0.1mm depth pocket, so you'll basically get 40 depth from here. Just that's how it's going to go together. So sort of a self-jigging feature here, and then that's what we need for the C-shaped part. We'll start with the plates. I've got the part clamped down now, so I've got it clamped onto this spoil board, and then the spoil board is clamped down to the bed, and then I've got 3 of these blocking pieces in just to try and stop it moving around. And then the idea is we'll bore out the holes in this side and the other side, screw those down to the spoil board, and then we can take some of the clamps off and put those just around the edge and finish off the rest of the features. I started by boring out the holes, which I could then use to screw the part down. I had to be careful that the part didn't move, so I ended up machining these holes on the slow side really. Could do with machining these a bit faster, but I wanted to make sure the part didn't move because it was only held on by those 2 clamps. Once I'd machined those holes, I could then screw the part down to the spoil board nice and securely, and then go a little bit quicker on some of the other parts. So here we're doing an adaptive just to machine out the recess. This is the second time I've used the Fusion 360 cam since AutoCAD changed what they give away with the free version. And yeah, I did notice in the middle where it would have normally done a rapid, that went at the standard feed rate, so very slightly slow. But overall, again, not a big hit for me being a DIY user, but I guess it could annoy some people. They are fresh off the mill, so it's not too bad a finish. You can see there's a little bit of recutting chips there. I don't have any air blast or anything like that, but pretty pleased, pretty accurate. So we've just got to clean up these edges, deburr the holes, and then these parts are done. Okay, we're finally there. That took a bit longer than I was expecting, but we got there now. So we cropped the ends off here, took a little bit out there. That's ready to weld that back up again. And so what we've got here, this is a bit of box sections that's the same as the piece on the drill press. I've just lined that up on the plate there. And then this will go on here. So yeah, that's nicely centralized. So we've just got to weld that back together there and dress that up, and then we'll just weld these on here. And then that's the lower bracket made. So we've got two of those. So we've got that one. And one for the other side, of course. Will basically go on like that. There's another one of these made for that. Right, let's set this up in the vise. Now I know that's going to fit. I think we'll just use this actually as a template, and we'll butt weld that seam together. Right, let's give you a quick update of where we're at now. So I've taken a little bit of time just trying to square these up and get these level with this surface, because there's going to be a big plate that goes on the front here. One of the problems really is that this box section is not particularly flat. It's got a bit of a concave section. It's not exactly 90 degrees. The column is probably not completely true. So I've just got it as close as I can. And if I really want to, when I put the final plate on, I'll have to shim the last bit. So I've got that in the 3 places. So the centre one and the top one there. They're pretty close. I'm not going to get any better than that because these are just not perfect. I could have machined them, I guess, but I think we'll just shim the plate to get that to fit. Alright, now what we need to do, so I've got those pretty close, you can see that there. So what I decided to do, actually rather my other plan, which was to use that little bit of profile, or that little pocket that machine out there to get those square, I realised actually I need to do it slightly differently. I needed to get all this square true, and then what I need to do is measure from here to the centre of that and here to the centre of that to get this plane this way reasonably central. It's not critical because the table will just move in 90 degrees to this anyway, but I needed to get that dialed in, and then I can put these brackets on. I've just put the chamfers on there ready, to be welded on, so they'll go on there. So once this is all squared up, I can get these screwed in and then just tack that on there, take it off, and then finish the welding, and then that'll be that complete. So we just need to get this square to this. Now I've got this level, just need to rotate it this way and get it square to the center of the chuck. Okay, I've just put a little twist drill in there, so we'll just measure. We can measure from anywhere really, but probably on the corner of this aluminium block's probably more accurate. So take that. That is 192. And the other side. Sorry, the camera's just in the way. Excuse me. Yeah, that is 190. So we just need to pull it ever so slightly this way. 192. I've gone the wrong way. Back in a minute. Okay, I went the right way this time. So we are now 190 exactly. On the other side. 190. I'd say within half, maybe quarter of a millimetre. So absolutely fine. It's not super critical because obviously the table will move. What's really important is that the table moves 90 degrees, so both these axes are 90 degrees. But just in case you want to square off a fence or something like that, it'd be nice just to have that as accurate as we can make it anyway. So I'm pretty happy with that. So now we can weld the brackets in place at the top, and we've got our position established. So we've got it pretty close up against there. It doesn't need to touch because that's what this bracket's for. That will make the last bit up there. So we'll get that in there. I've only got this one left, but we'll replace these with these mushroom head ones, which look a little bit nicer, but for now this is fine. Let's get that in. And there's one of these on the back as well, but for the purposes of just tacking it in place, we don't need that, so it'll be easy to do that when I take this all off and weld the back and weld this permanently. Right, so the other side. And now while we're here and putting this on, I'll point something out that I've just discovered. Oops. If you're a long-time viewer of this channel, you'll realise it's very annoying, to me anyway. Let's get this on and then I can show you what I mean. Yeah, that's good enough. Right. So you'll notice on this side, there's a gap between that plate that's flush with the top and this bracket. Maybe, let's measure it. Don't know if it's 1-2 millimeters. It's not much. Yeah, about 2 mil. As you can see, it's flush on the other side. So there's a 2 mil step in there. Now, what you'll also notice, we measure from the casting to there, which is how I set the position. That's 58, and you have to take my word for it, but on the other side, this also hangs out 58. So the only way that that can come up there and miss that by 2 mil is basically because the column itself can't be quite in the center of the casting, so this draft angle here and where that edge finishes there, you know, if you imagine that taper, the hole for the column is not precisely, it's off to one side, which means we get that when the whole thing comes together, because all the parts I made are absolutely perfectly made, but we just got that slight difference there. Won't matter about the functionality, but it just bothers me, you know. Anyway, onwards, let's get that tacked up. And here they are now, fully welded into place. So I'll just ground that back to make it look a bit nicer. So that's the first one. And there's the second one there. Right, let's get those fitted. And then that's another job done. Okay, just do these up loosely and then pull it up against there. Go somewhere about there. There it is, it's looking okay. So as I said earlier, I've got some of these button head screws on order, M8 button heads that look a little bit nicer, so they'll go in here, one at the back and 2 on there. But for now, it's obviously going to fit. So I've got the same on the other side. So it's the same round here. See, that was my last button head one there, so they'll all look like that eventually. So 3 in here and then 2 on there. Yeah, it's looking good. Okay, I'm going to wrap up the video there. Didn't quite make as much progress as I planned, but it is progress at least. So we've got those brackets sorted out there, and we've got all these box sections down here drilled, and they're all nicely dialed in now. So I think that's going to work. A couple of other things in there that you may have noticed. So we've got one. So there's a hole here, you can see it goes all the way through, and the idea of that is there's going to be some standoff brackets, some big chunky tubes that come off and hold both these posts onto the wall, just to stop, I don't know if you can see, but just sort of, I mean, it always shook around before, but now it's got a little bit more weight on it, so I want to tie that nice and securely to the wall, so it'll be fixed at the bottom, and then be one this side and one the other. And then down the bottom here I've drilled and tapped these. These will be some end stop pieces that go on so that the whole knee doesn't shoot off the bottom of the rail, so there'll be a stop there and a stop there. So the next jobs are just to take these off, clean them and spray them. They'll probably be sprayed up by the time you see the next video. And then I think we'll start working on the front plate that goes on here that holds the rails, getting that dialed in. Then we'll see where that takes us. We've still got to make we've still got the cover to make at the top, and then maybe I'll redo these pulleys. I mean, not immediately, probably some point in the future, because they have got a bit of run out and it does make the machine shake. I know it will be screwed to the wall, but it'd be better if it's running a bit smoother just to start with. Okay, once again, thank you for joining me. I hope you enjoyed the video. It took a little bit longer this time, lots of work pressures and family stuff. You know, you got to get that done first. But we have made some progress, so see you next time.